Are we really alone in the universe? What if the silence we hear from space isn't a sign that we're alone? What if it's a sign that everyone else is just really good at hiding? This is the chilling idea behind the dark forest theory, and it might just be the reason our radio messages haven't gotten a reply. In today's video, we'll be diving deep into some of the craziest theories about the universe that will make you feel you might just be in the Matrix. The dark forest theory. Let's talk about the biggest, most unsettling mystery in the universe, and a theory that makes a whole lot of cosmic sense while also making you want to go hide under your bed. For decades, scientists have asked a simple, chilling question. In a universe this vast and old, if aliens exist, where the heck is everybody? The silence is deafening. And according to one terrifying theory, that silence is the only thing keeping us alive. Do you ever wonder why we haven't found aliens yet, or at least any signs of intelligent life at all? It's because they're ghosting us. They know we're here. They're just secretly preparing to eat us all as exotic snacks. The dark forest theory is an answer to a question that has been nagging at scientists for decades: the Fermi paradox. Imagine the universe is not a bustling, happy place full of friendly neighbors and public parks. Instead, it is a deep and dark forest at midnight. You are a hunter hiding in the trees with a knife and a flashlight, and all around you are other hunters. You can't see them, but you know they're out there. You don't know who they are, what they want, or if they've got a better weapon than you. What's your top priority? Making noise and announcing your presence, or staying absolutely, completely silent? You could take a chance. Maybe they're friendly, or maybe they're hungry. Maybe they're 7-foot-tall robots that speak only in screams. They might join your campfire and have some s'mores, or maybe they'll peel off your scalp and eat your brains. Scary thought, right? So what do? Do you call out to the unknown hunters in the dark forest, or do you keep your mouth shut and hold your breath? This is the foundation of the dark forest theory, possibly the scariest explanation for why no one has responded to any of our signals. The reason we can't see alien civilizations is because they're all hiding. Unlike humans who are sending out radio transmissions and codes and waves and all kinds of stuff into space trying to make contact, all other advanced societies out there have figured out it's too dangerous to share your location with scary neighbors. The Fermi paradox. Perhaps the biggest mystery of all is, are we alone in the universe? The Fermi paradox asks, where is everybody? If the universe is so large, with so many galaxies, with billions of stars surrounded by planets, there is a high probability that at least some are habitable. There must be intelligent life out there somewhere. Some civilizations might even be capable of interstellar travel or communication, but we haven't found any evidence of them. The Fermi paradox was named after Enrico Fermi, who was a brilliant physicist extremely interested in alien life, particularly why extraterrestrials hadn't yet made contact with Earth. He thought, if our universe is nearly 14 billion years old and our planet is 4.6 billion years old, why has no one come over to say hello? 14 billion years is enough time for another civilization to emerge on another planet, figure out space travel, and start zipping around the stars. Statistically, there should be many advanced civilizations out there. This is the basis of the Fermi paradox. The paradox is that there should be millions of societies, but we haven't found anything, not even a space cricket. This is despite the fact that humans have been flinging radio waves into space, basically shouting out of a window for the last 100 years. There are many possible solutions to this paradox. As science fiction author Arthur C. Clarke said, two possibilities exist. Either we are alone in the universe, or we are not. Both are equally terrifying. The big answer to the paradox is that life might be much more rare than we think. Are we really the only ones? That's pretty daunting. How would only one civilization survive? That would mean that the conditions of the universe are inhospitable to life. The survival of just one civilization means that we are near certain collapse. If we aren't the only ones, maybe that means we're just too far apart. The distance in space is just too vast. Or they might be trying to communicate, but we just don't have the right technology yet to detect them. maybe they were already here, and that's where we got the pyramids from. Or, going into the creepier theories, perhaps they're watching us right now, like we use Google Earth to spy on uncontacted tribes in the Amazon. Or they are deliberately hiding. If alien life is out there, it should have picked up our signal by now. If you are yelling in that dark forest and others are out there in the stillness, they can hear you. But if they hear you and don't answer, that's when things get a little terrifying. The dark forest. This brings us to the dark forest theory. This idea was made popular by Chinese sci-fi author Cixin Liu in his novels The Dark Forest and The Three-Body Problem. If you've seen the popular Netflix series, you'll probably recognize the core idea of this theory. In his book, Cixin Liu paints a vision of the cosmos where every alien civilization is like a hunter in a dark, dangerous forest, all the aliens crouching, silent, their weapons drawn. Why? Because the first one to make noise might be the first one to get obliterated. The theory is built on three wonderfully pessimistic truths. One is that every civilization's #1 goal is survival. It doesn't matter if they're cuddly space koalas or six-legged bug monsters. They are all going to do whatever it takes to not become extinct. It's the ultimate universal law. Two, resources are limited. The universe is big, but planets, energy, and raw materials are not infinite. Eventually, civilizations will bump into each other and compete. It's a cosmic real estate war waiting to happen. And three, you can't possibly know a stranger's intentions. When you get a radio signal from a far-off planet, you can't tell if it's a friendly hello or a coded message to launch an invasion fleet. When you put these three facts together, the conclusion is chillingly simple and logical. The moment you reveal your location, you become a threat and a target. The other hunters don't have time to wait and see if you're friendly. The risk is too high. The safest, most rational move is to immediately eliminate any new signal you hear. It's an extermination order with a no questions asked policy. So the silence of the cosmos isn't an empty void. It's proof that every intelligent civilization that has ever made it off its home planet has learned the golden rule of the universe. Stay quiet, don't make a sound. And then there's Earth, hanging off the railing and shouting into the universe, "Hello, anyone out there?" The dark forest theory suggests that our efforts to send out radio messages into space aren't the sign of an optimistic, peaceful species. They're the equivalent of a toddler in a dark, monster-filled forest shouting, "Hey, I'm over here!" And if we ever get a response, it's probably not going to be a friendly one. Are we dumb, hopeful, ignorant, or just downright insane for yelling into the dark forest when everyone else is as quiet as a mouse? Should we be afraid? Now that you know the theory, do you think we should stop shouting into the dark? Or should we shout even louder? Astrophysicist and folklorist Dr. Moya McTeer points out that not all civilizations are going to act the same. On Earth alone, some people want to build communities and others want to destroy. Why would aliens be any different? Some extraterrestrial intelligences would hide because of fear, but not all of them. Yes, some aliens could be hostile and violent. Others might want to set up diplomatic relations and share technology. You have to ask yourself, is it worth the risk? I'm eager to hear your thoughts, so let me know in the comments. Unless every intelligent alien species agrees to stay silent, the dark forest can't stay dark forever. Someone might turn on a light or answer Earth's "you there" text. The vastness of space. Hopefully, other civilizations are more positive and friendly, like us. Well, you know, most of us. Seth Shostak, senior astronomer at the SETI Institute, agrees with other researchers that humans are not exactly being stealthy about the location of our home world. Seth said, "We've never even considered turning off our radars. It's just not going to happen." Yeah, humans haven't even considered not looking for alien life. And that really gives me hope that aliens are the same as us, looking for partners, allies, and friends. Because seeing as how long humans have been sharing our location pin with anyone who can pick up radio waves, if there were killer space robots out there, they probably already know where we live and what we had for breakfast. And don't forget, space is really, really big. Like you could fit all your fears and insecurities in it and still have room for 1,000 suns kind of big. Even if alien societies are scared of each other, The distances between stars are so massive that conflict seems kind of pointless. Why fire missiles across light years when you've got millions of untouched planets and asteroids to mine instead? Any civilization that can travel between the stars has an infinite amount of material at their fingertips. They can mine entire uninhabited planets or asteroids with more gold in them than we have on Earth, for example. Why bother with us? Intergalactic civilizations shouldn't have any real motivation for conflict. They have multiple planets to populate, plenty of materials, and presumably lots of wealth. What's there to fight about? The War of the Worlds. Actually, in life, there's always something to fight about. Maybe aliens are racist and don't like any life forms with two legs. Maybe they're tired of all our signals and space junk. Who knows why? Human history has taught us time and time again we can't help getting into a war of some sort. Ian Crawford, planetary scientist at Birkbeck, London, has asked some hard questions, such as, what if all the aliens are hiding because they are scared of a violent, world-ending race out there? Ian paints a disturbing picture in his theory. He's suggested that a hyper-aggressive alien civilization roams the galaxy, wiping out any emerging technological societies it encounters. Grim stuff, Ian, dang. Could there really be a rogue civilization traveling from system to system with a cosmic flamethrower, erasing every civilization before it gets too advanced? This rampaging civilization would explain why the galaxy seems so quiet. Maybe others tried to wave hello, sending out signals just like Earth is doing right now, and were immediately vaporized for their trouble. Maybe that's why we haven't heard anything yet. No one's answering the phone because they've all been disconnected. Maybe there's only one apex civilization allowed per galaxy, and they don't mess around with competition. So what do you think? Are we alone in a dark forest in space? Are we surrounded by hunters? Which do you think is scarier? And now for a quick break because it's shout-out time. I want to give a big thank you to Kristen Torrey and Thomas Alderman for supporting this channel. It means a lot to hear that, and thanks for being a part of this community. Be sure to subscribe if you haven't already and hit that notification bell so you don't miss out. We are living in a simulation. You know that sneaking suspicion you get when your phone predicts your thoughts or your printer refuses to work until you say something nice to it? That feeling that the world isn't what it seems to be, like you're inside of a machine? As it turns out, we all could be in a simulation, and scientists think they might be able to prove it. The Matrix is real. Let's rewind to 1999. Y2K paranoia was in full swing. Boy bands roamed the earth, low-rise jeans couldn't get any lower, and The Matrix hit theaters, sending a generation into an existential crisis. Neo dodged bullets, downloaded kung fu into his brain, and shattered the illusion of reality. Ever since, people have been walking around wondering if they're even real. Does this happen to you? The Matrix had such a profound effect on Dr. Melvin Vopson of the University of Portsmouth that he took it upon himself to investigate the possibility of our reality being a simulation. For real. Melvin Vopson's theory. Vopson isn't just a fan of science fiction. He's a physicist with a flair for drama and data. While most of us were using the COVID lockdown to make banana bread and try to cut our own hair, he was busy trying to recode the universe. That is ambition. Take notes, everyone. He introduced a theory called the second law of infodynamics, claiming it could prove all humans on Earth live in a simulation. The word prove here is critical because Vopson really thought he could confirm the simulation using data, laws of physics, entropy levels, and peer-reviewed papers. And I bet you're eager to know how he pulled it off. In classic physics, this second law of thermodynamics says entropy, which is really just a fancy word for disorder, always increases in an isolated system. Entropy has the universe on a one-way trip from organized and neat to sock drawer of doom. Vopson went looking for this same law in information systems, like data, digital bits, and genetic code. But he didn't find entropy spiraling out of control like the second law of thermodynamics says. He found the opposite. In his research, information entropy stayed stable or even decreased. It's such a confusing scientific topic that I'm going to revisit the sock drawer. What Vopson found would be like if you opened your messy drawer and found that all of your socks had rolled themselves up and neatly arranged themselves in the middle of the night. It was anti-entropy, the second law of infodynamics. Vopson realized that something didn't add up. If the universe is supposed to get more chaotic over time, why is the information within it seemingly getting cleaner, smoother, sharper? So he proposed a new law, the second law of infodynamics. It says that in digital and biological systems, entropy can go down, which in theory suggests there is some kind of optimization happening. You know who loves optimization? Computer programmers. According to Vopson, if our universe is running like a highly efficient simulation, streamlining, compressing data, keeping entropy in check, then it might just be a simulation. If it looks like a duck, walks like a duck, and quacks like a duck, you know where I'm going with this. He even said it outright in his latest article for The Conversation, writing, "A super complex universe like ours would require a built-in data optimization and compression in order to reduce the computational power and data storage requirements to run the simulation." In other words, you and I and everyone around us are all .rar files walking around thinking we're special, but we're in a simulation. Well, we may be in a simulation. Let's not throw a simulated parade just yet. Vopson's theory still needs mountains of testing, scrutiny, and a few Nobel Prize committee members fainting in the hallway before it becomes fact. The COVID glitch. Vopson didn't stop at physics. He took his theory to biology too, specifically to everyone's least favorite uninvited house guest, COVID-19. Vopson studied the genetic mutations of the virus and found a unique correlation between the information and the dynamics of the genetic mutations. Or, in layman's terms, the virus's mutations weren't as random as Darwin would have thought. Instead, they looked optimized. Again, there's that word, optimized. It's as if a computer program were changing the mutations in the virus to make it more effective. To Vopson, it's another blatant clue that everything from our atoms to our sun is in a simulation. If Vopson is right, and that's still a massive if, his second law of infodynamics could help explain everything from how electrons behave, to how life evolves, to how the universe is expanding without heat loss like it's using a cheat code. Nature tries to become more efficient all the time because it's a simulation. Even more dramatically, it could mean that humans are part of a vast, elegant computer simulation, running on some alien's gaming rig, or, God's hard drive. Embrace the simulation. Before you laugh all this off, just know that even ancient philosophers like Plato were asking if everything is an illusion and if life is nothing but a lie. Since the first man and woman opened their eyes, humans have wondered if all they see is real or a fabrication. And now I have to ask you the big question. Are you starting to wonder if deja vu is a glitch? If your dog is an NPC? If your life's loading screen is just your morning coffee? Whether or not we're all living in a sci-fi sandbox, you can't deny that this simulation has got some amazing storylines, plot twists, and patch updates. Simulation or not, Earth is never boring. Not for a minute. So what do you think? Are we in a simulation? Are we all characters in a video game? Are we each controlled by alien gamers messing with us like we used to play Grand Theft Auto? None of this is making me feel very good. Earth is trapped in a void. Scientists just dropped a theory so bold it makes dragons seem real and flat earthers look like cautious realists. Are you ready for this? It's even weirder than the simulation theory, so strap in. According to new research presented at this year's Royal Astronomical Society's National Astronomy meeting in Durham, our solar system is in a void. Earth and the entire Milky Way might be chilling inside a billion light-year-wide cosmic void. Just emptiness all around us. The idea behind this shocking new theory is that the Milky Way lives in a sort of empty bubble within the vastness of space. The bubble is so big, it forms an empty void with almost nothing inside of it, meaning that Earth and our little solar system is like a ghost town in the desert, separated and isolated from civilization. In the rest of the universe, aliens live close enough to borrow sugar, but humans, or Earthlings I should say, are in this bleak, empty pocket of space with nobody nearby to pet sit our dogs when we go to Alpha Centauri. Hubble tension. We may be in a void, but don't go packing your bags just yet for a more populated galaxy. While the void theory sounds like the setup for a sci-fi horror flick titled Alone in the Void and starring The Rock as an animated black hole, it might help solve one of astronomy's most persistent headaches. That headache is Hubble tension, a long-running cosmic mystery that's been annoying scientists since the early 2000s. It all started with Edwin Hubble, you know, the telescope guy. In 1929, Hubble noticed that galaxies are zipping away from us like we just said something weird at a party. He came up with the Hubble constant, a number that tells us how fast the universe is expanding. Today, there are two numbers to explain the Hubble constant. One is based on the early universe and uses things like the cosmic microwave background to determine the universe's expansion. This method suggests a slow expansion. The other method is based on tracking galaxies humans can see with their telescopes. The math from this method suggests a very fast expansion of the universe. But the truth is that no one knows which is right or what's even going on. You can't just go and measure the universe, no matter how badly you want to. We haven't even gotten our base on Mars yet, and astronomers are bold enough to think they can map the farthest reaches of space? The void theory. And this is where Dr. Indranil Banik from the University of Portsmouth swaggers into the chat with a theory that flips the script. At the beginning of 2025, Banik proposed that the Milky Way is parked inside a massive cosmic underachiever zone. Think of it like living in a cosmic suburb surrounded by bustling downtown galaxies. Our void has way fewer galaxies, stars, and general cosmic clutter than the rest of the universe. It's like moving into one of China's ghost cities. Those things are crazy. Because the denser regions around our void are pulling matter in with their gravity, the stuff inside the void is being dragged outward. That makes galaxies look like they're flying away from each other faster, confusing the Hubble tension. Imagine you're standing on a moving walkway in an empty airport while everyone else is stuck on the slow escalator. From your perspective, the world is speeding up, but really, you're just in a fast-moving, people-free zone. That could be us in our bubble. It looks like the universe is expanding, but we're just in a slow bubble trying to measure things way beyond the edges of our zone. It's all optical illusions messing with scientists. Fossilized sounds. Banik and team didn't just wave their hands and shout "void" like space wizards. They backed their theory with hard science, specifically with baryon acoustic oscillations, known as BAOs. These are the fossilized sound waves from the Big Bang, the ghostly echoes of the universe's birth. Crazy, right? Have you ever heard of fossilized sounds before? In the days prior to matter cooling and atoms forming, the sounds of the Big Bang birthing the universe rippled through the hot plasma of creation like cosmic dubstep. Today, those fossilized sounds act as a kind of ruler. If the measurements of those ripples match what scientists see in the void model, it gives their theory serious weight. Which is exactly what happened when Banik did the math. The BAOs seem to confirm that the Milky Way is in a dead zone, like an egg floating in the ocean, all alone in a seemingly infinite sea of nothingness. Before you go updating your social media bio to resident of the void, let's pump the brakes. This theory is still new, still controversial, and still makes a lot of cosmologists furrow their brows hard enough to cause a gravitational anomaly. The standard cosmological model, the one that humans have been working with for decades, assumes the universe is uniform when you zoom out far enough. Banik's idea challenges that, and it scares scientists. Nobody knows if we really are in a void, but I sure hope scientists keep asking crazy questions and cooking up crazier theories. Banik and his team are poking holes in the universe and rewriting the rules of universe formation, all while making us feel even more isolated. So the next time you stare into the night sky and feel a little lonely, try not to worry. It's not you. It's literally everything. We're in a freaking void. No wonder aliens haven't texted us back. How was the universe born? Say goodbye to the Big Bang. The Big Bang theory is on its way out the door. The most popular theory for explaining the creation of the universe might be wrong. Really wrong. So wrong that the universe may have been spat out of a black hole instead of just kind of exploding into existence. You might need a stress ball for this one. Your mind is about to be blown. Scientists are hitting the undo button on 13.8 billion years of accepted cosmology. The Big Bang Theory. For over a century, the Big Bang Theory has been the gold standard for explaining how everything, including us, stars, galaxies, and cats, came to be. The theory states that in the beginning, the very, very, very beginning, there was nothing. I know it's hard to imagine because how can there be nothing, but anyway. Within this nothing, a small, hot, dense point formed that was no larger than an atom. Then it rapidly expanded, forming the universe as we know it. The force from the Big Bang is still expanding the universe today, meaning out there at the edge of space, new galaxies are forming every single second. This all relates to the Hubble tension that I told you about earlier. Here's the thing about the Big Bang though. Astronomers have never been able to prove it, not through math, not through simulations. While the theory has been incredibly successful at explaining a vast array of cosmic observations and is supported by significant evidence like the cosmic microwave background, direct proof remains elusive, and that's why it remains a theory. And now it's not the only theory in town. The black hole universe theory. A new crew of researchers, led by physicist Enrique Gastañaga from the University of Portsmouth, is stepping up with a theory so convincing, it's asking the Big Bang to kindly see itself out. They propose that the universe wasn't born in a fiery, space-time tearing explosion. Instead, it emerged from the depths of a collapsing black hole inside a bigger, older parent universe. This would mean that our universe is a cosmic baby that gestated inside of another universe and then was birthed through a black hole, sucking our universe out of its parent and spitting it out into a new dimension. I don't know why that sounded kind of gross, so I apologize. I'm not used to talking about universes being born and, it's complicated. The new and improved black hole universe theory states that somewhere in a parent universe, a massive clump of matter collapsed. Instead of forming a black hole that ended in a singularity, the collapse rebounded. That rebound led to a new expansion, kind of like the Big Bang, but born inside a black hole. That new expansion was our current universe. It sounds like a theory that a bunch of university students would cook up on a weekend after eating too many mushrooms. But it's not! The team ran a series of simulations to prove that gravity inside a black hole could naturally give birth to a new and expanding universe. And unlike other attempts to fix the Big Bang's flaws by inventing new physics, this theory sticks to the classics. It doesn't need any bonus particles or mystery forces, just plain old gravity doing what it does best, creating and destroying. Gastañaga is currently working to prove this theory beyond the shadow of a doubt. He's involved in the Arrakis mission from the European Space Agency, which looks at faint, low-light structures on the edges of galaxies. If there's evidence of this universe inside a black hole model to be found, it might show up in the ghostly outskirts of galaxies that most telescopes can't even see. But if the universe was born out of a black hole, what does that mean for the Big Bang? Is the Big Bang dead? The theory's not dead yet. The Big Bang isn't going anywhere unless this new theory holds up to years of data, lots of peer reviews, and cosmological popularity contests. It could go the way of Pluto, shoved into the background of science once it's disproved. Sorry, Pluto, you were cool once. But what's exciting is that these bold new ideas are being tested seriously. Scientists are running simulations, publishing in peer-reviewed journals, and prepping real-world missions to gather proof. If Gastañaga's black hole theory turns out to be right, humanity will have to rethink the very beginning of everything again. But hold on, there's another theory taking the world by storm too, one that has a different explanation for how the universe was born, and it involves the James Webb Space Telescope. Want to check it out? Here we go. Galaxies that shouldn't exist. According to Professor Lior Shamir of Kansas State University, recent images from the James Webb Space Telescope could be poking holes in the theory of the Big Bang. In a new study published in the journal Particles, Shamir revives a long-dismissed alternative to the Big Bang theory. Long dismissed as in scientists already threw it in the trash, saying that no way does this explain anything. But Shamir thinks it does. He's pulled it out of the garbage like a raccoon stealing a half-eaten pizza. This controversial theory is known as tired light. It's a model suggesting the universe isn't expanding at all, not even an inch. After everything I've told you today about the endless expansion of the universe over the last 14 billion years, this is probably a little jarring. Shamir's theory states the universe is a stable, non-growing, perfectly ordinary place that definitely is not expanding. What's redshift, and why does it matter? In the 1920s, astronomers Edwin Hubble and Georges Lemaitre noticed that light from distant galaxies shifts toward the red end of the spectrum. This phenomenon is called redshift. They took this as a sign that galaxies are moving away from us, meaning the universe is expanding. The whole linchpin of this theory is light, and this is what became the foundation of the Big Bang Theory. It all boils down to redshift. But when you start scrutinizing the theory, it starts looking kind of flimsy. Around this same period in the 1920s, physicist Fritz Zwicky proposed a different explanation. He asks, what if light from distant galaxies appears redder, not because the galaxies are speeding away, but because the light is losing energy as it travels across space? Cool thought, right? Zwicky called this idea the tired light theory. Think of it like this. If you take the flashlight on your phone and point it directly into your eyeball, it's going to suck. It's going to be way too bright. I don't recommend it. Don't do it. But if you hold your light on one side of a pitch black football field way over there, people on the other side of the field probably won't even see it. Why? Because the light is growing weaker as it travels. Fritz Zwicky thought this same thing must be happening in space. He thought redshift might be the light of distant stars waning and growing weak by the time it reaches our telescopes, meaning that stars aren't flying away from us at 1,000,000 miles a second as the universe expands. Instead, the light of extremely distant stars is just weak and gives the illusion that they are speeding away from us. On paper, the theory is pretty solid. Still, scientists in the early 20th century shoved it aside in favor of the Big Bang Theory. Every time someone tried to resurrect it, they faced brutal ridicule. And then came the James Webb Space Telescope, and everything changed. What the James Webb Space Telescope saw. When the JWST launched, scientists expected to see the very early stages of the universe. They wanted to see young, newly forming galaxies that would support the Big Bang Theory. Instead, what they saw were large, mature galaxies. They looked toward the end of the universe, expecting to see galaxies forming at the tail end of the Big Bang, only to see the opposite. The galaxies James Webb revealed are ancient. It's like expecting to see the Empire State Building, but finding a clay hut. Shamir put it into words perfectly, saying if the Big Bang happened when scientists believe it did, then these galaxies are older than the universe itself, which obviously shouldn't be possible, unless there's something wrong with the Big Bang model. Revisiting tired light. Shamir's research analyzed redshift data from over 30,000 galaxies, using images from 3 different telescopes. His goal was to test how redshift changes depending on a galaxy's distance from Earth and its movement relative to us. What he found is that galaxies that rotate in the same direction as the Milky Way have higher redshifts. Galaxies rotating in the opposite direction have lower redshifts. And the farther away the galaxy is, the bigger the redshift difference becomes. This behavior doesn't match what you'd expect if redshift was purely a result of galaxies moving away due to universe expansion. It just doesn't fit with the Big Bang Theory at all. To be quite honest, tired light theory seems to present a strong counter-argument to the Big Bang. This could be the biggest astronomical shakeup since someone realized the Earth revolves around the sun and not the other way around. The tired light theory still faces major challenges though. But if Shamir's results hold up under scrutiny, it could force cosmologists to rethink how redshift works and how the universe really began. Thanks for watching! What do you think is waiting for us at the farthest edge of the universe? I think I'll have a stroke if I keep trying to understand what's happening out there. Let me know your thoughts in the comments. Be sure to subscribe if you haven't already, and I'll see you soon. Bye!